This lesson, we're going to be talking about relative frequency tables. And no, folks, that is not a way to keep track of how often your aunt and uncle come visit you. But seriously, let's get into our notes, the learning targets, all right? I can calculate, right? So we're going to be calculating values in a relative frequency table, and we're going to be able to describe what that means in everyday language. So again, interpreting mathematics. Awesome. First here, let's take a look at what you notice and what you wonder. All right, so we have two categories here. We have whether or not somebody is or is not a teacher, and then the degrees that are associated with that. Just for a side note, associate's degree is usually associated with 2 years of college. Bachelor's degree is associated with 4 years of college. And then master's degree or higher would be a bachelor's degree plus some. So once one is done with a master's degree, they've probably had 6 plus years of college, so on and so forth. So I think at this point, it's worthy of noting that if you look at the top column total here, this adds up to be 100%. And if you add up this column total, it adds up to be 100%. So those two add up to be 100%. Now versus if you add the row totals, these are not 100%, right? So 44 and 20 is 64%. And 52 plus 64 is over 100%. 16 plus 4, only 20%. So what's going on the row totals? Interesting stuff. And then I guess the other thing that you could talk about is that, well, let's see, I guess 4% here, 4%, what does that represent? That represents somebody, right? 4% of, I guess, of the adults that they talk to, 4% of them are teachers with an associate's degree, which doesn't strike me as possible. Can't be a teacher, at least in the state of Connecticut, without a bachelor's degree. Or that 20% of the people that they talk to, right? They talk to some adults in a school building. 20% of them were teachers, perhaps that didn't have that have a master's degree or higher. So not really sure. So this is just sort of getting you to think about how to look at and interpret, right? So we're really just focusing on the interpreting of what we see. But again, the big thing that I wanted to focus on was that this was 100% when you added up that, and that these did not total to be 100%. So that's the big deal. Let's move on. What we want to focus on now is just the counts and the fact that we have totals columns here, right? So there's 200 people were asked if they prefer dogs or cats and whether or not they live in rural or an urban setting. So whether or not they have a dog or a cat. And so what do we notice? We notice that 54 people out of the 200, right? 54 of them are urban dwellers with a cat versus 80% of, or 80 of them, not percent, my apologies. This is an actual count. The frequency, there's 80 of the 200 people lived in an urban setting with a dog. 24 people lived in a rural setting with a dog. Overall, there was more urban people than rural people. And overall, there were slightly more dog owners than cat owners. But I think there was the overwhelming majority of them, of the 200 people, 134 lived in the urban area setting versus only 66 in the rural, which kind of makes sense. There's fewer people in the rural setting to begin with. All right. I guess the very last thing I want to add in is that it says the actual values collected are in this first table. It's important. The actual values. These are not percents. These are the actual values. So as we transition into what the next table shows, right, is what percentage of the 200 people are represented by each combination of categories. So either the dog and cat category or the urban or rural category. So what I noticed, right, is that I brought along, again, these are the actual values versus now what we're going to do is we're going to look at percents, right? These are all percents. These are the actual values. These are percents. So what does the 27% pertain to? What does the 40% pertain to? So I see that there's 1, 2, 3, 4 different shading. And so the light shading is rural and dog. So what that means is that rural and dog, where is that in our actual values? rural is here, dog is here, so that's 24. And if I take the 24 and I divide by the 200, I get 12%. And so that is where this percent comes from. And so you should understand that all of these percents, all of the denominators are out of 200. So if I take the 42, say rural and cat, 42 divided by 200 is 21%. So the rural and cat is the 42 divided by 200. And the urban and dog. So notice every time I talk about and, I'm talking about something out of the 200. Urban and dog. So I'm just going to put this, the 42 over 200 is that 21%. Okay. And then the cat, let me switch colors, the urban and cat. So the 27%, urban and cat is going to be the 54 out of the 200. And then switch colors again. Where do we get that 40%? The 80 out of the 200, right? And when you take 80 and divide it by 200, you get 0.4, which is 40%. So as I look at this, when we add up all those percents, aren't we talking about all of the 200 participants that we asked to respond? Yes. So that's 100% of the 200. When you add up all of these percents, they add up to be 100%. So the 27%, the 21%, the 12%, and 40%, when you add all that up, what do you get? You get 100%. Why? Because those are the crashings of all of those two column pieces. So those ands are reflecting out of the total 200. And that's where that bar came from, and that's where those percents came from. This will begin to make more sense as we toggle through. Hang in there. So as we move through this, I'm bringing the actual values from the very beginning. So now we have two bars, and both of these bars add up to be 100%, which tells me this is 100%, right, of the urban category, and this is 100% of the rural category. So I guess we're looking at just the urban, right? So I just want to sort of restrict my eyes to just the urban. So all of the urban percentages, right, the 40% is going to be out of 134 because the urban total is 134. And then the 60% piece here, this is also from a total of 134. What's 60%? 80 divided by 134 is going to give me 59.7. So about, right, 59.7% or 0.597 was what I got when I divided 80, sorry about this sloppiness, 80 divided by 134 is going to give me this 0.597 or the 60%. Where did the 40% come from? Took my 54 and I divided by 134. 54 divided by 134 is going to get me 0.403, which is about 40%. And what happens when I add up 40 and 60%? I get my 100%. So this is the 40% and this is the 60%. And again, what is this talking about? 60% of the urban dwellers have a dog. Where does the 40% come in? 40% of the urban dwellers have a cat. How about over on the right side? On the right side, I see 64% and 36%. Which one is which? Well, this is the smaller light gray area, so that's the 36%. And this is the larger, so that must be the 64%. Of the rural dwellers, 64% have a cat. And of the rural dwellers, 36% have a dog. So a smaller percentage have a dog. And when I look at the rural counts, that makes sense. Less of them had a dog than had a cat. Out of the total, 66. So the 64% was 42 out of 66, and the 36% was the 24 out of 66. And this is, almost about a third, which is right around 36%. Makes sense. Should start coming together. As I move deeper in, I have two columns again, and now we're looking at cats and dogs. So I guess we're looking at horizontal totals now. So out of the 96, right? 54, let's change colors here. 54 of the 96 people that have cats live in an urban setting, right? So now I'm looking at this denominator. And so I want to draw an attention to this, right? 96 represents what? The total of cat owners. So out of the cat owners, right, 54 of the cat owners live in the urban setting, so which is about, I get 0.5625. So when I round to the nearest tenth, I'm going to say that that's 50, or nearest hundredth, I'm going to go to 56%. That's where that 56% comes from. So of the cat owners, right, 42 out of 96. And when I divide that, right, I'm getting 0.4375, which is about 44, right? 0.4375 rounds to approximately 44%, which is where that comes from. So these are horizontal thought process, right? So I'm looking, everything's over 96 for the cats. And then for the dogs, everything is over what number? 104, right? So 80 out of 104 and 24. So there's a overwhelming majority, which is the 77%, and there's an overwhelming minority, 23%. So when I look at the rural, right, the light gray represents rural, that's going to be 44% of the rural is cats, 23% for the dogs. And then down at the bottom, I'm going to have for cats, and the urban is going to be 56, and then 77. And when I add these up, 56 and 44 adds up to be 100. And when I add the 23 plus the 77, I get 100. As long as I've rounded correctly, I should be spot on there. And again, these bars represent, right, this is 100% of the dogs, right, looking horizontally just at dogs, and then looking horizontally just at cats, here's 100% of what's going on there. Of the cats, 44% of the cat owners live in the rural setting, 56% of them live in the urban dwelling, right? Not an overwhelmingly huge difference. There is a huge difference in the dog ownership. Most of the people who own dogs live in the urban areas. 77% of dog owners live in urban areas, while only 23% of dog owners live in the rural section. Okay, so now let's try to put this together all at one time. So what I'm going to do is I'm going to discuss this using the number 54. Okay, so when I look at that number 54, I could divide that 54 by 3 different denominators. First off, I could divide it by 200, right? So we did that. And 54 divided by 200 gets me 0.27, which is 27%, right? I multiplied by 100, or I moved the decimal over 2 spots. So 27%. So what does 27% represent? That represents urban and, right, and cat. So of the 200 people, right, of the 200 people, 54 of them live in an urban area and have a cat. Or I should say that 27% of the 200 people own a cat and live in an urban setting. Next, I'm going to switch a color to yellow. So now I'm going to look and think, well, just about the urban people. 54, how many urban people are there? There's 134 overall. Out of the 200 people, 134 of them in the total of the column live in an urban setting. So out of just the urban people, how many have a cat? 54. And what's 54 divided by 134? We get 0.402, or 0.403 technically, which is 40.3%, or approximately 40%. So what does the 40% represent? 40% of the urban dwellers, because that's all I'm looking at. I'm not even looking over here. I'm just saying 54 out of 134. 40% of the urban dwellers own a cat. 27% of all the people asked were urban dwellers and owned a cat. But now I'm just looking at urban dwellers. And the last version is going to require us to first erase the mess here. The last version, right, is going to require us to look horizontally at just cat ownership. So I'm going to sort of scribble out everybody here. And I'm just talking about cat owners. How many of them are there? 96. And what happens when I divide 54 by 96? I get 0.5625. So round that to the nearest whole percent. So that's a 2, which is smaller than a 5. I'm just going to say 6%, 56%. So what does 56% represent? Of the 96 cat owners, 56% of cat owners live in an urban setting. 40% of who? That's the vertical piece, right? 40% of urban dwellers. How do I know that's urban dwellers? Because that's what the 134 represents, the total of urban dwellers. So 40% of urban dwellers own a cat. 50% of cat owners, because that's the denominator, live in an urban setting. And since 200 is the denominator here, of all the people that were asked if they preferred cats or dogs live in a rural setting or not, 54 of them have both urban setting and cats, or 27% of the people surveyed live in an urban setting and have a cat. So really, if you want to interpret this, it's all about paying attention to what the denominator represents. So what I want you to do now is to do your best to answer these questions. Now you should have a fighting chance. Are you going to get them all right? No. But I want you to do this first on your own, then we will discuss and debate. The back end here, analyzing a study with 2 treatments, right? In an experiment to test the effectiveness of vitamin C. Isn't this interesting, right? We're talking about vaccines right now and things like that, and what does and does not work, right? You have to do an experiment, a controlled experiment to decide if we can have some sort of causation, connection, to test the effectiveness of vitamin C on the length of colds. The old age argument. 2 groups of people with colds are given a pill to take once a day. The pill for one of the groups contains 1,000 milligrams of vitamin C, while the other one contains a placebo pill, also known as a sugar pill. It's generally just a pill of sugar, right? And so the people don't know if they're taking the vitamin C or if they're taking the placebo. And the researchers record the results in a table. Now, you know me, the first thing I'd like to do is to what I refer to as finish the table, right? Let's see. We got 16 plus 17. Let's add that up. We get 33. And 27 plus 53, and we get 80. And then we'll add horizontally 16 plus 27, and we get 43. And 17 plus 53, and we get 70. 70 plus 43 gives us 113, and 33 plus 80 gives us 113, so that's good. That tells me that my total is good. So I guess the first thing is, how many people did they work with, the researchers? 113. That's an important piece. Now for question 1, the researchers want to know what percentage, right? So we're going to start dividing here to the nearest whole percent. So we need to round to a whole percent. The people are in each combination of categories. So this is just like the very first scenario with the cats in the rural situation, right? This is the and, right? So what is 14%? Now they have it sort of, very convoluted. They have all the numbers. I'm really not a fan of looking at it like this. I would prefer to have the totals. So I'm more of a fan of the, 16 divided by 113, because that's what all those values add up to be. So what's the denominator in all of these? 113, right? Whoops, 113, 113, 113, right? And what's the top number? The number that's in that position to begin with. So there's 1, 2, right? 1, 2, 3, 4 boxes. Here's the 4 numerators. The denominator is the same for every scenario here. Boom, done. Next, move on. In part 2, the researchers noticed that among the participants who had colds that lasted less than a week. So again, we're looking at only the colds that last less than a week. So I guess I'm not looking at them. So all I need to know is what's 16 plus 27. Again, this is why I like to have that total, right? So I got the 43. And so that's my total. So in this scenario, I have colds that last less than a week and then colds that last more than a week, right? So among the participants who had colds that lasted a week or more, group B, and then group A lasted less than a week. So I'm going to focus on the 37%. Where did that come from? This 16 plus 27, which is 43. And then this is going to be 43. And then down here, this is going to be a different denominator. What's that going to be? That's going to be focusing on only the colds that lasted a week or more. So I'm going to scratch this out and think about the 70 people that represents. And so I guess I got the 70 and the 70. Okay, so now I'm thinking horizontally, right? Horizontally. So obviously the next scenario is going to be focused probably vertically. I don't know, I'm just guessing. Finally, the researchers want to know that among the participants in group A, so that's all here. So how many people were in group A? So I think that's 16 plus 17 again, right? And I get that 33. And then while I'm here, I know that the total of this column was 80. So on some of these, we're going to be dividing by 33, and on some of these, you're going to divide by 80. Then you're going to go on and try to answer these last few questions. And again, we will iron out all of this in class. But first, you got to, learning is a process of first getting yourself confused, trying to get yourself unconfused by thinking critically and logically. And then lastly, discussing it with a group. Now, you can discuss it with your classmates before we get back to class, and then we'll discuss it as a class. And then ask questions during class. That's the process of learning. Lastly, you can go through the summary on your own. I'm not going to read through this. This is just but a part of it. But read the summary, right? This will help solidify the learning process, solidify what you just learned. And there may be something in the summary that helps you with some of the questions you just tried to answer, right? You attempted. So I will see you soon, and we will discuss all of this then. See you later.